We have looked at our factored form before, and from our factored form we figured out how to use our x-intercepts, but we're going to build on that a little bit and talk about it in relation to solving our quadratic equations. Okay, so remember our factored form looks like this. Okay, remember when you're getting it to factored form, you're doing what multiplies to a times c but adds to b, right? And then there's a variety of ways that you can factor from these two pieces of information to get to here. You should always be checking for a greatest common factor and pulling that out first. Remember, this a value tells you both if it's opening up or down. So if a is positive, it opens up. If a is negative, then it opens down. And then it also talks about, or it tells us the steepness in relation to our parabola. Okay? So we have several words for x-intercepts, and we use them relatively interchangeable. So we can use x-intercepts, zeros or roots, are any values for which of x for which f of x equals 0 or y equals 0. Remember, f of x is really 0, so these two are meaning the same thing. Okay? So what we're going to do is to solve for our x-intercepts is you set each factor equal to 0 and solve. Okay. Oh, look, it has that information down there. So if a is bigger than 1, it's a stretch. If it's less than 1, it's a shrink. So this goes stretch is skinnier and shrink is wider. And then remember, if it's opening up, we call it concave up. If it's opening down, then it's concave down, and it's determined by the a value. Okay? So here we had, in the last chapter, we had found our shortcut for our x-intercepts. So let me explain how we get that shortcut. So here, what we're really saying is in order to solve this, we're setting this whole thing to solve our x-intercepts. That means our y is 0. So if our y is 0, that means in order to multiply to 0, one of these has to be 0. So this is the reasoning behind why we set each one of these equal to 0. So each factor, this factor gets equal to 0, this factor gets set equal to 0. So when we solve, here we have to undo our order of operations backwards. So we're going to add 1 first, so we get 2x equals 1, and then we're going to undo timesing by 2 by dividing by 2, so we get x is 1/2. On this one, we just need to undo adding 7, so we subtract 7, so we get x is -7. So our shortcut from here to here is that you change this sign and then divide by the coefficient of x. So -7 divided by 1 is just -7. Change this sign, which is +1, divide by this coefficient, which is 2, so 1/2, right? Now, you can solve for it each time, or you can use that shortcut. Now, it's really important that you remember the difference between writing the factored form and finding your x-intercepts, your solutions, or your roots, or your zeros. So if I want factored form, it has to be written with your sets of parentheses. And then from there, you change the sign. So what happens frequently, an error that gets made, is that people will have these signs in the diamond and then keep the signs the same when they go to the x-intercepts. Or vice versa, they'll get the diamond answers, and then when they put it factored, they'll switch the signs for factored. So you have to remember that the diamond signs are what goes in the factored, and then when you're setting it equal to 0, that's when you switch the signs. So you need to separate that in your mind. Now, if we look at this one might throw you off a little bit because of this -4. So if we look at it, -4 is just a greatest common factor. So if we set that factor equal to 0, notice we would get -4 equal to 0. Well, that doesn't ever happen. So that can't change anything. The other way that you could look at this is you could say, well, I could divide by -4 on both sides, so then I get 0 equals 2x plus 3 times x minus 5. So the -4 with no variable, any number out here just a constant with no variable, is not going to impact your x-intercepts or your zeros or roots. Okay, so here we can again do where we set 2x plus 3 equal to 0. And if you're forgetting what the way is, you should remember from your diamond to your sets of parentheses, you set it equal, or you just do the signs as they are. Then you can go the long route and remind yourself if you've forgotten. So here I would subtract 3, and I get 2x equals -3, and then I divide by 2, and then I can say, okay, well, from here to here, what happened? Oh, I changed the sign and divided by that number. So if you forget the pattern, you can always go back and just set it equal to 0 and see, okay, well, here I would have to undo subtracting 5, so I add 5, so then x is 5. Okay. So here, if we look at this one might be a little bit different for you as well. So let's take a look at this one. So we have 0 equals -1/2 x times x minus 2. Now this has a factor, a greatest common factor that's out in front, but it also has a variable with it, which is different than this one that we looked at, where it was just a number. So these are different scenarios. This is still a factor, and this is still a factor, so I can still go the long route and set each one of those equal to 0. So I can do -1/2 x equal to 0, and x minus 2 equal to 0. So here we need to undo subtracting 2 by adding 2. So we get x is 2. On this one, we need to undo timesing by -1/2. Well, you can undo timesing by -1/2 by timesing by -2, or that's the same thing as dividing by -1/2. So then we get 0 equals x. Okay? So we get x equals 0 and x equals 2. If you think of -1/2 x, that's really plus nothing, right? So if I change this sign, that's 0, and then if I divide by that, 0 divided by anything is 0. So our pattern of change this sign, divide by this number still works. You just have to remember that this is really plus a 0. Okay. Now, when we're looking at finding our x-intercepts, what we're really doing is solving that equation for when our y is 0. So there are some other times when we would like to solve our equation, or when we look at it and we're not necessarily just looking to see in terms of a graph what the x-intercepts are. So when you're solving a quadratic equation, you set each of the factors equal to 0 and solve for the variable. Okay, so these ones solve the quadratic by factoring out the greatest common factor. So we want to look for our greatest common factor in each one of these. Notice each one of these has 2 terms, right? So I'm either thinking, okay, this could be a difference of squares, or I just have a greatest common factor. So it should be thinking greatest common factor because that's what the instructions told me. So notice each one of these is divisible by 4 as well as an x. So our greatest common factor here is 4x. If we divide out the 4x, remember factoring is really dividing. We're going to do 4x squared divided by 4x, which is just x. And then if we do -12x divided by 4x, that's -3. Okay? Now we can set each factor equal to 0. So you can go the long route and do 4x equals 0 and x minus 3 equals 0. So you divide by 4, so x equals 0. Oops, I dropped a part of my equal sign. So plus 3, so x equals 3. So we get 3 and 0. So these two things here are our x-intercepts. Or you could think, okay, 4x is really 4x plus nothing. So I change the sign of nothing, which is still nothing, divide by 4, which is nothing. Change this sign, so positive 3 divided by the unsaid 1, which is 3 divided by 1, which is 3. Okay? So that's still an option that you have to do your shortcut from here, from your factored form to your x-intercepts, your roots, or your solutions or zeros. We use all of those words. Okay? So if we look at this one here, we have a common factor. This one has a common factor both of numbers and of x's. So if I take out my common factor here, the common factor is 5x. So when I factor that out, I get 5x squared divided by 5x is just x. And then 10x divided by 5x is 2. Right? So if we go our shortcut from here, this is plus nothing. So change nothing, the sign of nothing, which is nothing, divided by 5, which is nothing. Here, we change the sign, so -2, divide by the unsaid 1, which is -2. So those are my solutions, or my roots, my x-intercepts, or zeros. Okay? So now let's try some that's just our normal kind of factoring, where it's not already factored for us. Okay. Now remember, there's multiple ways that you can factor, and I don't care which way that you're factoring. One of the ways that you could do is guess and check. Both of these are prime numbers, which makes this a great option for guess and check. So 2x and x, and 1 and 1. So I'm looking and saying, okay, with these, this is 1x, and this is 2x. So to get to negative x, I need the 2 to be negative and the x to be positive. So negative 1 plus, or sorry, 1 plus negative 2 is a negative 1. So that means that this has to be negative, this has to be positive. I check this sign. Positive times negative is negative. So then that's my guess and check. The other ways that you can do it are you're multiplying to negative 2 and adding to negative 1. So you're using 2 and 1. This is negative. Then you can do your box. So you've got x squared and negative 1, and then you're using your two numbers from the box, so minus 2x plus x. Factor out your common factor of x. Factor out your common factor of 1. Common factor of x. Common factor of 1, but this is negative, so I take out a negative 1. Oh, I missed writing a 2. That's problematic. Let's not do that. I wrote x squared instead of 2x squared. So then here, that'll change several things. So here, this is a common factor of 2 and x. This still has a common factor of negative 1. So then we get 2x plus 1 and x minus 1. If you're doing the payback method, where you pay back the 2's and then you reduce, so this gives you 1 and negative 1, and then you got 2x plus 1. So you'll do 2x plus 1 and x minus 1 equals 0. Okay? Now, when you're showing your work, you have to show me your factored form and then your answer. You cannot go from the diamond straight to the answer. This will also help with the errors that happen with the signs. So notice my signs here, the negative goes here and the positive goes here. And then when I go to solve, we get x's. Change this sign, divide by this number. So that gives us negative 1 divided by 2. And then we've got this one is we change this sign here and divide by this one. So we get x is 1. Okay. Now we have another scenario. So just to remind you, on this problem here, you would want to take out the common 1. Okay. So if we're looking here, I want to show you some other ones. Now, sometimes it's not set equal to 0. So the first thing that you have to do is you have to set it equal to 0. Okay. So if we look at this one, it's not set equal to 0. So I have to set it equal to 0. So I'm going to subtract the 6 to the other side. So we get x squared plus 5x minus 6 equals nothing. So multiply to negative 6, add to 5. That's 2 and 3. Both are positive to get to positive 5, but that doesn't multiply to negative 6. So let's try 6 and 1. Oops. I need 6 to be positive, 1 to be negative. That adds to 5. That multiplies to negative 6. There's a 1 in front, so those are my sets of parentheses. So we do x plus 6, x minus 1 equals 0. So you have to show this part as part of your work. You don't have to show me the diamond, but you do have to show the factored form. Then you don't have to show this next part. You can show the x plus 6 equals 0 and x minus 1 equals 0, and then show this part, right? Or you can just go skip straight to there using our pattern of change this one, divide by this one. Change this sign, divide by this one. Okay. Let's look at another example. So let's try this one. Okay. Now, typically, I like my x squareds to be positive, so I choose to move everything over to where I have a positive x squared. So I would choose to move my 7x over to this side. You can still move the x squared to the other side, but then you'll just have to factor out a negative. So I choose to do it this way. Both get you to the same spot. So you would, if you had done it the other way, you would have negative x squared plus 7x equals 0. So here, notice there's two terms. So I should be thinking, okay, a difference of squares or that there's a common factor. Well, I look and these have a common factor. So on the blue one, the common factor is just x. So that gives us x minus 7. On the purple one, it would be a negative x. So that gives us x minus 7 equals 0. So notice these look different, but when I solve this one, it doesn't actually matter because this would be plus nothing, and then divide by 1 or divide by negative 1. So nothing divided by 1 is 0, and nothing divided by negative 1 is still 0. So either way, you get 0 and 7 as your answers. Okay. Let's look at this one. Now here, we've got multiple x squareds. So I want to move the x squared so that they're all together. If I want a positive x squared, I want to move this one to the other side so that I end up with a positive x squared. So you can do it the other way, but I need to move everything to one side. So I need to move all of the left to the right or all of the right to the left. Both are fine. Now, when I move them around, I make sure that when I write them, it's in descending order. So squared, then the x, then the number. So here, if I subtract 2x squared and then I subtract 15, notice there's no like term with 15. These are a like term here, so that gives us 3x squared, keep the minus 4x, then the minus 15 equals 0. So now it's in the format of ax squared plus bx plus c, which makes it really easy to set up my factoring. So the factoring, we want to multiply to a times c. So here we're multiplying to negative 45, and we're adding to negative 4. So we've got 1 and 45, 2 doesn't go into it, 3 and 15, and then 5 and 9, and 5 and 9 are the one that work. So I need the 9 to be negative. I double check my signs. That's really negative 4. That's really negative 45. I pay back the 3. Or you can, I haven't showed grouping yet. If you do grouping, you do 3x squared minus the 9x plus the 5x minus 15. So these remain the same. And then I split this one based on these two numbers. All right. So then we group the first two and we group the last two. It still needs to be set equal to 0. This has a common factor of x and 3. So 3x squared divided by 3x is x. Negative 9x divided by 3x is 3. My second set of parentheses, I have a common 5 and it's positive. 5x divided by 5 is x. Negative 15 divided by 5 is negative 3. These two things match, which is what you want with grouping. So these match, and then we write the leftover part, which is this. So then we get x minus 3 times by 3x plus 5. But that's just setting it equal to 0. Okay? Again, you don't have to factor by grouping. You can do either with the box or you can do with the payback takeaway. All of those are fine. I just need you to be able to factor quickly and correctly. So we can set each one equal to 0 or we can use our shortcut. So change this sign. So negative 3 divided by the 1 out in front is negative 3. Change this sign. So negative 5 divide by the 3 that's out in front. So negative 5/3. So that is how we're solving our quadratic equations with factoring.